Okay, so we have this problem number 619, which we have to determine the force in each member of the truss and state if the members are in tension or compression. So we are given that the value of P1 here is 8 kN. Okay, so 8 kN, and then P2 is 12 kN. Okay, P2 is 12 kN. Okay, so we need to find the force in each member of the truss. So there are 5 members, which is number 1 is D, E, F, B, and also C. Okay, so the first one we need to find the member in joint D. First thing we do is we make this free body diagram. So this point D here, we have point D, and then the force of FDE, and also the force of FCD. So we are given that the P2 is 12 kN, and then there is a angle here, angle theta. So first we're going to find this angle by using tan theta. And how do we get this 2/1 is from this 1, and this is 2 meter. So theta is equals to inverse tan of 2 equals to 63.44. And then we calculate the sigma Fy equals to 0. In this case, the y-axis is FDE. So the formula would be FDE sin theta, which is 63.44, minus 12. This is minus 12, equals to 0. So FDE sin 63.44 equals to 12. And then we substitute FDE equals to 12 over sin 63.44. And we got the value equals to 21 kN. And the state would be in tension because FDE is moving away from joint D. Here, it's moving away here. Okay. Next, we find the sigma Fx equals to 0. The formula would be FCD minus 21 cos theta 63.44 equals to 0. And FCD would be equal to 21 cos 63.44, and after we calculate we will get 17.23 kN. And the state would be compression because the FCD here is moving towards joint D. Okay. Next, we got joint C. We draw the free body diagram here. This horizontal line, and then moving upwards here. We got this free body diagram. And then we will calculate the sigma Fy equals to 0. And in this case, the y-axis is the FCE, which will also equal to 0. And the sigma Fx would be FBC here minus 17.23 from here equals to 0. So FBC would be equal to 17.23 kN. And the state would be compression because the force is acting towards the C, joint C. Okay, next. For joint E, joint E would be here. the free body diagram would look like this. So in here we have angle, sigma angle, and if we calculate this sigma angle by using tan equals to this is 2 meters and this would be also 2 meters, so tan 2 over 2 equals to tan inverse equals to 45 degree, and we'll get 45 degree. So for the sigma Fy, the formula would be FBE sin 45 minus 21 sin theta 63.44 equals to 0. And then we substitute FBE sin 45 equals to 21 sin 63.44, and we divide it, we would get the answer 14.1 kN, and the state would be compression because FBE is moving towards joint E. For the sigma Fx, the formula would be FEF plus 21 cos 63.44 plus 41 cos 45 equals to 0. And then we move the FEF to the other side, and we would get the answer would be 24.6 kN, and the state would be tension because this FEF is moving away from joint E. Next, we got joint B. For the free body diagram, this joint E, there will be a force from FBF, FBE, and also FBC, as we get from before. FBE is 14.1 and FBC is 17.23, and we are also given the value of P1 here is equals to 8 kN. So for the sigma Fy, the formula would be FBF minus 8 minus 14.1 sin 45 equals to 0. And then after we calculate, we would get 20 kN, and the state would be tension because this FBF is acting away from joint B. And for the sigma Fx, the formula would be FAB minus 17.23 minus 14.1 cos 45 equals to 0. And then we move the FAB to the other side, we get negative 24.6 kN, and it would be positive because the state of FAB here is acting towards joint B. And for the last joint F, we can get the free body diagram from the image here. So there will be an angle theta here, and the value of FEF, which we get from before, is 24.6. So the sigma Fy would be equal to 0, and the formula is FAF sin 63.44 minus 20 equals to 0. And we divide 20 over sin 63.44, we will get 39 kN, and the state would be compression because this FAF is acting towards joint F here. It's acting towards joint F. and the sigma fx equals to 0 will be equal to FGF plus 24.6 from the FEF, 24.6 plus 35 cos 63.44, and we add the 24.6 plus 35 cos 63.44. After we calculate, we will get 53.3 kN, and the state is tension because this FGF is acting away from joint F. That's all from my explanation. Thank you.